Today we are going to discuss about the smallest chapter in your 12th standard physics, that is electromagnetic waves. In these electromagnetic waves we have very small portion to study. One thing is you have to study about the nature of electromagnetic waves. After that, what are the waves which is coming under electromagnetic waves, how they are produced and what are their uses. Such very small topic only is there. So we will start the topic. So first we will discuss about what is this electromagnetic wave. So you know this electromagnetic wave is a combination of electric field and magnetic field. So electromagnetic wave means it is a combined electric field and magnetic field. This electric field and magnetic field will be in phase and they will be perpendicular to each other. And the direction of propagation of this wave will be perpendicular to both these. For example, if the electric field is along x-axis and the magnetic field is along y-axis, then the direction of propagation will be along the z-axis. So that's the way. So all these three things will be perpendicular. That is electric field, magnetic field, and which direction the wave is moving. So these three things will be perpendicular. So generally we will take along x-axis we can take electric field, and along y-axis you can take the magnetic field, and along z-axis we can take the direction of propagation. So you think about such a wave, the wave which is along moving along z-axis. So we can draw that wave. The drawing that wave is very important. Many times just for drawing this wave they ask for the examination. So you just listen here how to draw this wave. So I am drawing. So here let the x and y be little bit different. So this is x-axis, this is y-axis, and this long one is z-axis, because we already told this is moving around z-axis like that. So first we discuss the electric field is along x-axis. As the electric field is along x-axis, I am drawing the electric field like this. Okay, this is the electric field. Electric field is like this. Now I am drawing this electric field, so for easy understanding I will draw like this also. So the electric field, this is the electric field which is along x-axis, and here it will be along minus x-axis, because it's just like a sine wave. So this is our electric field. Now just what I told is the magnetic field will be perpendicular to this one. So perpendicular means it should be parallel to this y-axis, in this axis. So if I can draw it like this, it should have a three-dimensional look. I think you understood how it is. So if this is like this and this is like this, to get that three-dimensional look I can draw it like this. So this will be like this, that is parallel to y-axis. Here it is to that side, so it will be like this. I think you are getting in a three-dimensional look for this one. Okay, so this is the way of drawing the electromagnetic wave. So this wave is moving in this direction, that is clear. Wave is moving in this direction, and our electric field is oscillating like this, and the magnetic field is oscillating like this. So this is E, it is the electric field, and this is B, it is the magnetic field. I think this picture is clear. Now if you take the equation for this one, the electric field is along x-axis. So we can write electric field as Ex. X says that electric field is along x-axis, which is equal to E0. What is this E0? Is the maximum value of electric field. E0 sine kz minus, should be careful in that one, omega t. So when time advances, it is moving along this direction. Okay, when time advances. So this is the equation for electric field. See here carefully, it is Ex is equal to E0 sine kz minus omega t. And magnetic field is given by By, which is equal to the same in format it is, because they are in phase. So instead of E0 it will be B0 sine kz minus omega t. So the wave equation and all we already studied. in the 11th standard, that waves chapter, we studied this one. So Ex means electric field along x-axis at a particular time, and E0 means its maximum value, and sin kz. What is this k? I will tell you now. This z is the direction, in which direction it is going. It is going along z axis. So if such a equation is coming, means you should know this. Here one z comes means it is along z axis. For example, if a question is coming, a particular equation is given, and in which direction the wave moves, means along with this k which is coming. So in that direction it will be moving. It is moving in the kz direction. Minus omega t will come here. Okay. So here also B0 is the maximum value of magnetic field, and there is a relation between B0 and E0. That also I will tell you. Then same way kz minus omega t. This omega is the angular frequency of the wave. Angular frequency means 2 pi. This omega will be equal to, omega is equal to 2 pi nu, where this nu is the frequency of the wave. Okay, so if it is different electromagnetic wave, that corresponding frequency will be there. So this omega is 2 pi nu. And what about this k? This k is given by, k is equal to 2 pi by lambda. This is also very important. K is 2 pi by lambda. So if you want to find out the wavelength from such an equation, if such an equation is given, what is the wavelength? Such a question comes means you make the equation in this format, and what is coming here in the place of k? That is along with z, which term is coming? That one you take, that is k is equal to 2 pi by lambda. You take lambda here, 2 pi by k will give the lambda. That's a way of finding out the wavelength. Another way of finding out wavelength is there, that is wavelength into frequency is given as the speed. But there is a problem. Always that wave may not be traveling in the vacuum. If it is vacuum, speed of the electromagnetic wave or any wave, electromagnetic wave in vacuum can be taken as c. So c is equal to lambda into nu. So from there you can calculate. But it is not mentioned whether it is moving in the vacuum or in other medium. So there will be a confusion. So you better to take using this one, k is equal to 2 pi by lambda. If you take wavelength, that will be better. That is the best way for taking wavelength. And frequency you can take from here. In the place of omega t, what is coming from there, you can calculate the frequency. Okay, so generally the question coming based on this one will be like that. One equation will be given, and they will ask you what is the equation for the magnetic field of this wave, and in which direction it is moving. The direction you can get from here, frequency you can get from there, wavelength you can get from here, and the same equation if you write B0, then we can get the value of magnetic field also. So this will be along x-axis, and here you have to write perpendicular to that one, y-axis you have to write. So the relation between E0 and B0 also, after this one I will explain. I think this much is clear. So the main problems or main questions coming on this one is, one is to draw this one, another is this one will be given, and based on this one equation you have to write the equation for magnetic field, or magnetic field is given, based on that one you have to write the equation for electric field. Okay, so the other some other relation also is there, that relations also we will study. So only such relations we have to mention in this chapter. Okay, apart from this one, we can see one more thing. This omega, I told you already that the speed of light is, or speed of electromagnetic is c, which is frequency into wavelength. But this is in the case of vacuum. If it is not moving in vacuum, we will write this v. V is the speed in that particular medium. And this omega can be written as omega is equal to 2 pi nu. This all relation you should know. Omega is equal to 2 pi nu, and omega is equal to c k. Right, this also you can write, because this 2 pi and lambda we have a relation like this. If you take, you can write like this also. And for c, another relation also we studied previously. C is equal to 1 by root of epsilon naught mu naught, or mu naught epsilon naught. That also we done previously in another chapter. We done this one. Okay, so this all relations to connecting each other you should know. Okay, so this also C is equal to lambda by into nu. This is applicable when it is moving in vacuum or air, we can use. Now again I told this one how to relate this is, if this equation is obtained, you have to write this equation, means you should know the value of B0. There it may not be written as E0, some numerical value will be there. So how to get this B0 value? So that is this E0 by B0. This is equal to C. In the case of our vacuum, if it is in the case of any other means, that velocity V you have to take. Or you can write B0 is equal to E0 by C. So V0 you can get like this. You can use this equation. Okay. So the ratio of the electric field and magnetic field is C. So what is the meaning of that one? C is a very big number. Ratio of electric field and magnetic field is C, means the part of the magnetic field is very small. Because that ratio is C means the magnetic field is very less. So this much things you should note down. And this some 1 mark 2 mark question can come. So you are okay with this one, then you can use all these things. Okay, this also I told you, C is equal to 1 by mu 0 epsilon 0 or mu naught epsilon naught. One more thing, if this same thing, if it is not in this vacuum, then the same equation we can write V is equal to 1 by root of this mu naught and epsilon naught is the permeability and the permittivity of free space. If it is not free space, then it will be mu into epsilon. That naught will not come. Okay, which medium is there? That medium you have to use. So it's little bit common sense you have to use along with this one. So I will just stand away. You just note down all these things. Okay, and I think if you pause now, you can note down all these equations. So something related to this one you can get for the examination. You have to expect that one. Now one more thing, when this light or the electromagnetic wave is falling on a surface, it is carrying some momentum. So that is also very important. Generally we will say these electromagnetic waves are not having any mass and all, but there is a momentum that we studied when we studied about the photon. So that momentum is there. So due to that momentum, some pressure also will be there. Then when something is coming and falling somewhere and it is applying some momentum to that one, means it can create some pressure also. That is called as radiation pressure. Radiation pressure also, that will be the force by area. Okay, so nothing will come more about that one, but you should know there is something called as radiation pressure. Radiation pressure is due to the momentum of the particle or the force due to the radiation. Okay, that is negligibly small value, but there is something like that. Okay, so that also you have to remember. So these are the basic thing about these electromagnetic waves. In this electromagnetic waves, another topic also was there about the displacement current, by taking an example of a capacitor and all. It is there in your textbook, but due to the COVID pandemic, this year syllabus they changed a little bit, so they removed that one. Okay, so if you are watching this one for this 2020-21 year, that topic is not there, but coming year after that what happens, I don't know whether they will again include. So now I am not discussing about that one, because for this year it is not there. That's why we are not discussing about that one, about the displacement current. Once the syllabus changes, you have to study the displacement current also. Just this one is made for this year. That's why I am not discussing about that one. Now we will discuss about the electromagnetic spectrum. That is the total electromagnetic waves. What are the waves coming under that one, and how much is the almost range, frequency, wavelength and all. What are the waves present in electromagnetic spectrum, and in which frequency range all these waves are coming, and what are the uses, such things. Okay, so first here behind me, here you can see that this is the electromagnetic spectrum. So in this electromagnetic spectrum, in order for you to understand easily, you can start with the visible light. So you can see here this small part which I marked here, this is the visible spectrum. In the actual case, this visible spectrum, even this much is not there. Small part only, that is in the total electromagnetic spectrum, visible spectrum is very small only. So this visible spectrum, you see, it is coming in the center of the electromagnetic spectrum. See here, this visible spectrum, it is having a wavelength from 400 nanometer to 700 nanometer. So the wavelength corresponding to 400 nanometer to 700 nanometer, that is called as visible spectrum. That is our big GR. That is violet, indigo, blue, green, yellow, orange, red. Like this, I written in the opposite way because I written in the increasing order of frequency. So here the smallest frequency is red. When frequency of the red is small, then you can see the wavelength is the highest wavelength. That is 700 nanometer is the highest wavelength. So that is red color. And here we can see violet color is having 400 nanometer. Okay. So this is violet is having more frequency. The energy of the electromagnetic waves, you know, h nu, it depends on the frequency. So here you can see if you take this electromagnetic spectrum in this one, the red is having more wavelength, so its energy will be very less. So if you want to get what is the corresponding frequency, what is the method? Wavelength into frequency, that is lambda into nu is 3 into 10 to the power 8. So you put the value of this 700 nanometer, you have to put 10 to the power minus 9. 700 into 10 to the power minus 9 into frequency, that will give 3 into 10 to the power 8 meter per second, that you will get. So you can calculate the value of frequency. Almost the frequency range is coming in the range of 10 to the power 14 hertz. That is, visible light is coming almost in the range of 10 to the power 14 hertz. So that is visible light. Now you see here visible light is there, means this entire graph is coming in such a way that this is the lowest frequency and this side is the highest frequency. If you take wavelength, it is opposite. This is the highest wavelength and this is the lowest wavelength. And you understood in the center we have a visible light. So visible light also, the lowest frequency is red and the highest frequency is violet, already we discussed. Now something less than red, that is called as infrared. So this side of the visible light we will get infrared. Infrared means, infra means inferior, less than red. We are talking in terms of frequency. So infrared is coming this side. And the other side, you see, the other side is UV. UV means ultraviolet. It is more than violet. That's why ultraviolet is coming that side. So infrared is here, ultraviolet. So this is the way you have to remember. You have visible light and one side is red and another side is violet. And this side of the red is infrared and that side is ultraviolet. Now ultraviolet is having more energy than visible light because frequency is small. Now more than ultraviolet, we have the next higher level, that is X-ray. X-ray is having more energy than ultraviolet. That naturally you know X-ray can pass through your flesh and you can take the X-ray photography. So X-ray should have more energy. So see here, this side having more energy. So this is dangerous radiations. That is, X-ray is dangerous. Okay, X-ray and this gamma radiation is having the highest energy. The high energy electromagnetic radiation, that is called as gamma radiation. In nuclear physics also you will study gamma. Okay, in nuclear physics you will study alpha, beta, gamma, like that 3 radiation. This alpha and beta are not electromagnetic radiation, they are particles. Alpha means helium nucleus and beta means electrons. And gamma means it is not like particle, it is a high energy electromagnetic radiation. So in the electromagnetic spectrum, the highest energy is for gamma radiation. You can see the frequency is very high, 10 to the power 23 hertz. That's why it's having very high energy. So that is about gamma radiation. You see, wavelength is very small, 10 to the power minus 14 meter only. So very small wave with a very high frequency. So highest energy will be for gamma radiation. And this X-ray also you should know, the X-rays frequency is coming in the range of 10 to the power 18 hertz. 10 to the power 18 means starting from 10 to the power 16 to 10 to the power 20. There is no exact boundary for that one. If 10 to the power 20 comes, whether you can call it as X-ray or gamma ray, don't take tension like that. Because 10 to the power 20 can be called as a high energy X-ray or a low energy gamma ray. Just like the age of 18 or 19, whether you have to be called as a man or a child, means it's a big child or a small man. And like that you can call the same way. If it is coming in the border, it can be a X-ray, high energy X-ray or a low energy gamma ray. Like that you can call. The exact boundary is not there for that. Okay. So almost from 10 to the power 16 to 10 to the power 20 is X-ray. So this X-ray range you should know. And highest one is gamma ray. And here UV is also coming. Use of each radiation I will tell you later. Then the other side of visible I told you, we have the infrared here. And less than infrared we have the microwave oven where you are using to cook. So that is using the microwave. And after that this microwave, so see, after this infrared whatever is coming, this is what we are using for the communication. Okay, this microwave is used for our mobile phone and all we are using microwave, and this is a short wave. For radio we are using short wave. Okay, and here the FM, TV, FM, these all things are used for communication. Okay, this low frequency or the long wave you see the wavelength is coming in the range of kilometers. 10 to the power 7 means it is something like 10,000 kilometer and 1000 kilometer, 1 kilometer, all those things very high wavelength. Okay, so for radio it is in meters and kilometers. Okay, the frequency will be in few meters to kilometer for this radio. Okay, so the TV radiation is coming here, and along see here. So these microwave, this radio communication, mobile phone, all these things are having energy less than the visible light. So you see here, so many people are telling this microwave radiation, it will make so much problem for you, it will ionize all those things. So you should keep one thing in mind, the energy of this microwave, mobile phone, everything is less than the light only. The one which will kill you is this side. Okay, so you don't worry too much about the radiations and all, but better to keep little bit away, because too much, even if it is a low energy, too much means if you are keeping too much time near to your head and all, minor problem can come, but it is not that much energetic. Just if you are sitting in sunlight for so much time also, you will have problem. Same problem you will get that one. Okay, don't worry too much about the radiation. Okay, and so much radiation, so many people are making use of that one. Okay, the radiation is there, it's a problem and all. So by seeing, if you study this one properly, you know this radiation, where it comes, how much it will be there. And one thing you have to remember then, this microwave is coming here, we are using microwave for cooking also. High energy microwave can be used for cooking food. So when too much microwaves are coming, it can be powerful. Okay, but normally that is not that powerful. It is, this power is less than light only. Okay, so I think this is clear. And here also you see our visible light also from 400 nanometer to 700 nanometer, and the center of that one is coming 550 nanometer, which is yellow and green. That's why you will be so much happy to see that colors which is coming in the center, because edge red you will feel it as very sharp red, I cannot look at that one. Blue also you will feel like that, but this yellow and orange, it is coming in the center, you will be feeling a little bit pleasant to see that one. If you see your some dress, t-shirt and all, if you take, you see the yellowish color, we will feel it as very much bright. Actually yellow is not that bright and all, we are feeling, because it is coming in the center, which is more comfortable for us. That yellow and green, the greenery, by seeing we are happy because of that light color which is coming in the center of the spectrum, that you can see from here. Okay, so everybody is happy with this one. When it goes to edge, you will feel a little bit problem, violet, red and. So that's about this electromagnetic spectrum. So generally a simple doubt will come, whether I have to by heart all these numbers. If possible, do it. Otherwise you should have an almost idea how it is. Anyway, this X-ray you remember. X-ray, where it is coming you remember. Okay, so X-ray, and above X-ray you have this gamma ray. So that frequency you can say, okay, this is above X-ray, should be gamma ray. Then something is coming, it is less than X-ray, but it is more than visible light, so it should be UV. Like that, some logical thinking can do that one. And again, it is not, it is very close to visible, so it should be infrared, less than this one, like that. You have to think like that. I think the idea you got. Now, next thing is, you have to think about what are these things and what are the uses of this one, how it is produced. There is a direct simple chart is there in your book. Using that one also you can find out. Okay. So first thing is the radio waves. So radio waves means its wavelength is something greater than 10 centimeter. 10 centimeter to more, that is 0.1 meter or more, that is called as radio waves. Then how these radio waves are produced? Radio waves are produced using some electronic circuits. Actually, we can say by using the rapid acceleration of electrons in the circuits. Just simply by using the electronic circuits, we can produce the radio waves. Then how we can detect the radio waves? How we are detecting the radio waves? Radio station is producing the radio waves. For your radio, small antenna will be there. If you are using FM radio inside the car also, for the car, small antenna will be there. Small antenna, so we can detect this one using some antenna. So radio waves is very simple. What is the use of radio wave? It is used for communication, and its wavelength is more than 10 centimeter to above. And it is used by, it is produced by the electronic devices, by this oscillations and all. And for communication we are using. And then from your textbook you can remember for FM which frequency is used, for TV communication what frequency is used. That just a little bit idea is there, means good. Previously that is coming as a part of the other one also. What is that? Our communication system, like that one chapter is there. But here now that communication chapter is removed. So whether to study it or not, that is left to you. Because here it is coming, there also it was coming. That's why previously we used to teach it. Now it is coming here, so you can just for FM radio, which frequency is FM, you may be remembering that one. Generally 91.5, so some 90 comes up. So it is 87 to 107. megahertz. Because the FM name itself, FM 98.2, like that 90 something is coming. So 87 to 107, that is megahertz, that is used for FM. So you just in the textbook you remember. If I tell all the values I can get here, and if I tell also you won't remember. Later you make a list which frequency is used for which one. Keep an idea about that one. And for TV, which one is used? One thing you should remember. Radio is here you can see this is used for radios, and TV is here, and again this short wave is used for radio communication, and almost range you can remember. Okay, exact number if you are not remembering also. So that's about radio. Main thing is radio is used for communication. Next one is microwave. So microwave means it is, you see here it is coming. Microwave is between infrared and the radio waves. Now microwave is produced using, we cannot produce same way, okay. So microwaves are produced by using a particular thing that is called as the klystron valve. Klystron valve means it's a particular thing. It will look like a bulb, okay. So it is some electronic component type thing that is called as klystron valve or magnetron valve. Klystron valve and magnetron valve is there. This is the material which is used for producing the microwave, and the microwave will have a wavelength from it is less than 10 centimeter, and it will be up to 1 millimeter. Between 1 millimeter and 10 centimeter, that wavelength will be there. That one. And for detection of this one, we will use a particular thing that is called as the point contact diode. This entire thing is there as a table in your textbook. Okay, so this point contact diode is used for detecting the microwave. Then what are the use of this microwave? That's also very important. First thing already we told, it is used in the microwave oven. Okay, actually that pronunciation is microwave oven. So this in the microwave oven we are using. There, how it works microwave oven? Inside that we will keep the food materials. These food materials will be having some water molecules. So when you pass this microwave through that food materials, these water molecules will have the same frequency of this microwave. So resonance will take place. So this water will start to vibrate, or actually it is not vibration, rotation. Okay, it will undergo this movement. So when it is moving too much, these chemical bonds will break. When chemical bond is breaking, it will heat up. So that's the way. Actually we are not directly heating it. When the microwave is passing, the water molecules will get split. Because of that one only it is getting heated up. Okay, so the entire technology behind that one is not required, but you should know it is based on this resonance of the water molecules. Okay, so the microwave, the food is getting heated up. So that's why some water content is there, then only you can use in the microwave. The food material, if some water content is there, so that water will oscillate same with the same frequency of the microwave, so that it will get cooked up. So that's the method how this one works, means that's the thing. Now one more thing, this microwave is used in the case of radar. Radar, when you write the expansion of radar, it is radio is coming. Still what we are using is microwave. I think you know what is radar, for finding the position of the aircraft or something. If you see, you may have seen in movies and all, something thing will be rotating in the airport, continuously rotating like this. So it is taking the radiation, and a green graph into something will be rotating. So where is the position of the aeroplane and all we are finding out. So that is called as radar. Okay, radio detection and ranging, radar means. But even though we are using the word radio, the way we use it is microwave. You should know all the uses. Okay, microwave is used in radar, and microwave cooking you are using, and in mobile communication also, from tower to tower they will use microwave, from one tower to another tower. And the radio, the frequency which they are using from the tower to your phone is something like the radio waves only. But microwave, from one tower to another tower, you might have seen above the tower something like a drum. That is the microwave antenna. Okay, we are using microwave for that one. So for cooking we are using, for communication we are using, for radar we are using microwave. Okay, so that's about the microwave. And after microwave we have to study about the infrared. Infrared radiation is also called as the heat radiation. Infrared radiation is also heat or temperature means infrared radiation. The frequency also you see in the table. Okay. Otherwise it will take too much time. Simply I am telling you cannot remember it. So, okay. So infrared radiation is, so any hot object will produce infrared. So if you use an infrared camera, you can find out the temperature. So if you want to take this remote sensing, what is the temperature of Earth at different places for weather thing and all, the satellites will use this infrared photography. And again your TV remote, when you press the remote, infrared radiation is going from the remote. So TV remote one, then remote sensing from the satellite, we are using that one, and the hot bodies photographs and all, if you want to find out, we will use infrared. And one more thing about infrared is night photography. You might have seen along with the our CCTV camera, around that one some small infrared lights will be there. So for night photography also we are using infrared. Note on all these points. And after that, visible light, no need of explaining anything about visible light. You know visible light, just frequency only you remember. Now next one is ultraviolet radiation, UV radiation. So UV radiation is having more frequency than our visible light. So where this ultraviolet is used? It is used for killing germs. Water purification, RO water, reverse osmosis, we are purifying the water, then you will pass that one through some this UV radiation so that it will kill the germs and all. So our mineral water bottle and all we are getting, in that one it will be there, this one UV purified, so purification we will use. And again somewhere purifying some other material also we will use, just like what is that, in beauty parlor and all, they are using scissor, this one, that one and all. They will be keeping inside a box. So UV radiation is there, so it can kill the germs. So for killing the germs, we will use this ultraviolet thing. Another one is called as the Lasik treatment. Lasik treatment means if you have some eye problem, you are using specs. If you don't want to use specs, you can go for a Lasik treatment. By doing the Lasik treatment, we can remove the specs. After some age of 18, 19, you can do it if you don't want to use specs. So this Lasik treatment, they are using UV radiation, UV laser they are using to shape your eyes, cornea and all, so that later no need of using this what is that, our specs. So that Lasik treatment we are using, okay. And one more thing, this UV radiation is coming from the sun, and who helps you to escape from that one? You studied junior class, ultraviolet radiation coming from the space, that is blocked by ozone layer. That also you have to remember. So if one more question comes, which electromagnetic radiation is absorbed by ozone layer? So ozone layer absorbs UV radiation. Okay. Then what are the other things? So UV also we discussed, the frequency also. Then X-ray. What is the use of X-ray? X-ray radiation, you know what is X-ray. X-ray is having high frequency. Where it is used? In medical you are studying. For medical users, you have to take the X-ray photography. If your hand broken, you will take X-ray photography. So X-ray is used for that one. And how these X-rays are produced? X-rays are produced by the electronic transition. So what about this light? How light is produced? That also is there. The light is also produced by the transition of the electrons only. The electrons are undergoing transition in the atoms. And this UV and X-ray, same thing only. It is electronic transition only, but it is having more energy. So it will be in the inner shells. This is normal electronic transition. This UV, X-ray and all will be using some the transition of electrons in the inner shell. Okay. So inner shell transition will make UV and X-ray. This one is the normal transition. And X-ray is one use I told you, to take the X-ray photograph. Any other use? Chemistry? To study the crystal structure. When you are studying the crystal structure, you study in a closed packing and all. So to study the crystal structure, we will use X-ray. That is called as X-ray diffraction. Using X-ray diffraction techniques, you will study the structure of the crystal and all. So there also this X-ray is used. Now what comes? Gamma rays. So gamma rays, where it is used? From how it is produced? It is produced in nuclear reactions. So gamma rays we cannot make it in another. So where if you want to make gamma radiation, it will have, you have to use nuclear reactions. So gamma rays is so powerful, it can pass through. You cannot, light we can block with your hand. This X-ray you cannot block with your hand, but your bones will block it. But gamma ray can go up to 30 centimeter, that is 1 feet thick steel wall it can go. It's highly powerful, or we can say it's having very high penetration power. Here the penetration power energy is very high, here it is very low. But these waves will bend, these waves will not bend. Radio waves will bend and come inside. This gamma rays will not bend, it will penetrate and go. Okay. So that's about gamma rays. Then where the gamma rays are used? nuclear, it is produced in nuclear reactions. It is used for making some nuclear reactions, and another major use is this gamma radiation is used for cancer treatment. You might have seen cancer radiation therapy. Cancer patient is there, for him radiation is given. So they are using this gamma radiation. Okay, that is coming in the border, gamma radiation. Sometimes people will call it as the high energy X-ray also, because it is coming under gamma, but it is, I told you, there is no sharp edge for that one. So gamma radiation is used for medical treatment. So I think all this radiation and the uses and already the table once more you see. Just if you want to take note of these things, I will just stand away from this one, so that now you can take a screenshot, and from that one you can write this one. Okay, but nothing serious to write in that one, because in detail it is there in the textbook. I just explained this one. The numbers, if I explain 100 times also, you have to remember it. So you take the table from the textbook and study that one, each use, how it is produced. You make a simple table about the entire thing. So this 3 mark chapter, you can do it very easily. 3 or 4 mark chapter you can get very easily. So we will wind up these things here. If you have any doubt, you ask.